Okay, welcome back again, and this is the Chipmaster, and in this video series I'll be looking at, well, repair a Dell laptop here, and it's written on it, says that computer works, just not picking up the charger to charge the laptop. There we go. So it says computer works, right, just not picking up the charger to charge the laptop. Right, so that's the issue. So I'm gonna connect the charger. I already have the charger prepared already for the sake of this video and time. So I plug it in and I'm gonna turn it on. Alright, so we have the Dell logo. Alright, this is the first time I'm turning on this thing. Alright, as I'm repairing this on the spot. No prior check. Or anything like that. Alright, please wait while it's starting up. Okay, so set the password. Oh, there's an X on the battery. This is a Inspiron. Yeah. So it has an X on the battery. Right, so there's an X on the battery there. See if I can zoom in on this. Oh. Oh. So I accidentally hit the laptop there. Let's go into the BIOS first. I believe the Dell Inspirons have the, and the latitudes, I believe. No, the latitudes have the section for checking the battery status and the, okay, battery AC adapter not installed. It says not installed. Oops, see? Each time I shift the, it seems the port is bad. Let me shift it. Yes, as you can see, there's a white light there. See the white light? If I move it, it goes. So it says the adapter is not installed. Let me power it up again so I can shift this thing. Alright, pressing it again. Pressing the F2 key. Waiting for that Dell sign. It's not on? Oh damn. It's off. This thing is not good. This thing is not good. This is not good. Oh, alright, I thought it was broken. Alright, I can't move this laptop. I have to make it stay stable, unless it's gonna switch off every time. Because I'm not using the DC power supply because I don't have the charger the connection that I had, they don't want to go bad, so I don't repair them. I don't replace them anymore. I just use genuine Dell chargers. And sorry about that. It's not turning on again now. I got the caps lock light in the on the keyboard. It's not turning. It's on, but I'm not seeing anything on the screen. I'm not seeing anything on the screen. I got the caps lock. Oh, it seems like it's turning on now. Oh, so the battery. Let me see if the RTC. Is that the RTC battery? Seems it's inside of the. All right, AC adapter not installed there. Carry this all the way. See if I can pick up a zoom. So it says here, AC adapter not installed. Alright, so it says AC adapter not installed. Right, so it's not picking up the adapter. So I'm gonna shut it down and I'm gonna take it apart. Okay, and it's a Wistron based motherboard. Interesting. I thought it was a Compal based motherboard. Oh, the battery was not plugged in. Look at that. Why didn't they plug in the battery though? Or somebody was here before. Let me see if this thing can turn on. Let me see if this thing can be turned on from battery. Battery is dead. And this is why when I was in the BIOS I could not see that it was actually in the BIOS. See the battery in the BIOS. So I'm connecting the charger now. Just want to get a piece of the overhead. There's the power. So the battery level is 0% there. Battery level 0. And AC adapter not installed. Alright, so let me just... Oh, it's on battery now. So the battery is taking some charge. But even though it turns on the charger, it still says that the AC adapter is not installed. You cannot detect the wattage of the charger. It's impossible. Can't detect the wattage of the charger. That one was tight. Okay, so the board is out. Okay, so the motherboard is out. Alright, so I'm just here doing some visual inspection. Alright, looking at the DC jack, because I realize each time I rock this thing, it shuts off. Alright, so let me zoom in. I like the zoom on this camera. It's a very powerful zoom. Very powerful. I don't even have to use a microscope. Alright, this camera I'm using the Sony HDR CX405 camcorder. Very powerful camera. Alright, so I'm just inspecting under the DC jack area here, under the connector right here, for any suspicious activity such as a burn or explosion or mildew. Alright, so I'm just scanning the board, as you can see, and I don't see anything. This is the first rule when repairing for most electronic devices: use your eyes. Alright, looking at these. resistors here, which is connected to the keyboard connector for data, audio, and the board seems pretty fine. Alright, so first of all, I'm going to check if I'm getting a waveform with the oscilloscope on the center pin. So the center pin for these Dells is right here, the white wire right here. So this is the center pin wire, this white wire. Right, so I'm going to check here for a waveform. If I'm not getting a waveform, by default I should be getting 3.3 volts here. So let me get the, I always call it the third camera, rather the fourth camera. For the multimeter. Okay, so I've connected the fourth camera, and now let me see more. So I'm going to check the voltage on the white wire there. If I'm getting 3.3 voltage there. So that's 1, 2, the third pin, and I'm not getting 3.3 volts. I get 19, right? I get 19 volts, but I'm not getting 3.3 volts at the third pin. 1, 2, 3. No voltage. Alright, let me check the resistance. So on the Dell computers, the center pin is powered by the board. So this board sends 3 volts to the DC jack through the center pin inside of the DC jack. So the center pin, which is inside, which is the PSID pin, which is designed by Dell to determine the wattage of the charger, right? So that the computer can know how much power or wattage it needs in order for it to charge the battery. So if it cannot sense this, then it can't charge the battery, which is a safety precaution, which is designed by Dell. So this 3 volt is designed to send the 3 volts from the board to the tip inside to power the DS2505 chip inside of the charger. Alright, so I'm gonna check the resistance. And there's a problem. That's a short. We should not be getting that. So this is why the charger is not sensing. Right? So this is creating a short on the PSID line, so the adapter cannot be read. So the EC, the main purpose of this is for the EC to read the adapter information. Right? So once the EC can read the adapter information, then it will send the charging instructions to the charging chip through the SM bus, or we can call it the I2C line, right, to charge the battery. So this is a charging chip. So this charging IC is connected through an SM bus, or we can call it I2C line, clock and data, which is a 2-wire communication right, which is transmitting signals from data, and a constant clock. So once the constant clock is there and we have data, then the EC will then send the charging instructions to the charging IC, and then it will start charge the battery. So because of the short circuit on this connector here, on the pin of the PSID pin of this connector, the adapter information, the DS2505 chip inside of the adapter cannot be powered. So the DS2505 chip inside of the charger needs 3.3 volts in order for it to power that DS2505 chip, so that the EC can read the signal through that serial connection there. I wonder if everybody gets what I'm trying to say here. So this is how Dell designed their adapter supply, and the purpose of this is that anybody can plug random charger inside of this thing. We can plug a HP charger, you can plug a different charger that can fit inside, but that center pin might have some voltages coming out of it. So for the HP chargers normally have about 12 to 15 volts depending on the charger, right? Some of them are generic, some may have up to 10, up to 13, up to 15 or 17 volts coming out. If you plug that 17 volts inside of the charger, what will happen that it can send that 17 volts to the EC and burn the EC. So you don't want that. So that is why Dell designed this protective way, in order to protect the EC, and also a way of creating an OEM specification for the Dell, right? So this is done through the PSID pin. So we have a short here. So let me see if I can find a schematic, right? And the board number, as you can see here, is 187. All right, the board number. So the board number is 18789-1, and this is a Wistron motherboard, right? And let me see if I can find a schematic. Okay, so I have found a schematic here. There's no schematic currently for this unit. Oh, okay, sorry. Alright, so this is the board, and I need to find the DC jack. And it's on the CPU side. This is the LCD connector. It's the flex. I hope this is the correct one. Dim 1, dim 2. Oh, this thing is flipped around. Let me see if I can mirror it. It didn't work. Alright, so this is it, the DC jack. DC in one. So this is power. As you can see, DC in. And this side, oh sorry, this is ground, as you can see here, ground, and this side is power. This side is left not connected. This side is a center pin, sorry. PSID, sorry, here it is. So this pin is not connected. This is ground, this is power, and this is the PSID section. As you can see, PSID, right? And if I go over to this side of the board, it should tell me exactly where this signal interconnects with the other section of the board. And, I'm not seeing it. It's not telling me where it's connecting. Let me go over to the parts. PSID. This one is a bit different. Oh, this is the keyboard side. So it's supposed to be. Oh, here is it. PSID. I couldn't see that. So PSID, this is a ED, it's a static diode. Let me check those static diode under the microscope. Okay, so it's right up this side. Okay, so there's no schematic, so I'll have to use the board view with experience to see if I can repair this. Okay, so on the schematic it says that there's a diode. Oh, let me get the So I'm measuring the resistance of this diode here. So it's a QQ. Here is the diode. Alright, so that's connected to ground, and once I connected to power, and that's not it because I was getting 0, 0. Let's see. Hey? Okay. So on the center pin here for the white wire, as you can see, the white wire is here, and that's connected to this pin, and it's now 57. It has increased a bit, so it was correct. So it was on that diode, I was at the correct diode. So I was getting 57, 56 on this pin, which is the 4th pin. And then I flip it around on this pin, and that's 57. So I'm going to remove this diode out of the way. Alright, just checking that transient suppressor diode there. Alright, so this diode is what connected to the center pin of the DC jack, the PSID. Alright, this says Q, 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 so this is Q, Q, and Q. So these three MOSFETs are represented by these Q348, or Q4348, Q7401, Q4304, and there are these three right here, and this one is Q4349, which is for this one. Let me remove this diode out of the way. This is about degrees. In the tweezer. There we go. Alright, so let's do this. Out of the way. Let me measure. And I get 600 and 700. Goes on that line. I will have to find, if that's the case, I will have to find a anti-static diode in order to repair this, because it serves a purpose. Should be replaced. Oh, let me set this to voltage. Alright, let's check if we're getting 3.3 volts. Indeed, we are getting 3.3 volts. Now I will check the waveform now to see if the waveform is on the oscilloscope, and once I get the waveform, it is perfectly fine. So I'll just replace it with the replacement diode. So I'm now connecting to the oscilloscope, where I will see if I get a waveform. If I get the waveform, then that indicates that the laptop is fixed and the battery should be charging. Alright, so I'm gonna connect the probe of the oscilloscope to the same pin number 3. Let me set up my controls first. So I'm setting my volts per division to 2 volts per division. And my time base is going to set to 500 microseconds, and my edge type will be falling edge. Setting that to falling edge, and I will capture this signal. So take a look at the screen. I'm plugging in the power now. Let me try again. There we go. And there's the waveform. Let me do it again one more time. Alright, so I remove the power. I connect the charger. There is the waveform, and that indicates that the EC is reading the charger, and it is detecting the wattage of the charger and all the parameters of the charger, and it is reading successfully. So if you go in the BIOS now, you should be able to see the wattage of the charger. Okay. Now I'm gonna replace this with a diode, and this is a 3.3 volt Zener diode, which has a reverse voltage conduction, and this is basically acting as a stabilizing diode and also preventing static. So it can act as an anti-static diode or a stabilizing diode to prevent any overvoltage from spiking on this line, induced from any electromagnetic interference or plugging in the incorrect charger, to protect the EC from burning. So I will pause and see if I can find the Zener diode. Now, as I found a donor board. Now this Zener diode, normally on the Dell Latitudes, it will be a different type of diode, which is having 2 legs, which is connected in a, what we call it in a same way, directional transient suppressor diode or Zener diode. But this one is a regular anode cathode Zener diode. So as you can see here, I have a donor board here, and this is a Wistron based motherboard from my HP ProBook donor. As you can see here, I have a diode here, and you can see PD4405. Right, there's PD4405, and this is connected to the battery line, which is these 2 pins here, as you can see. And this is used for ED, which stands for ESD, which is for anti-static, right? And this anti-static diode, which are normally here on here, which is connected through these 2 resistors here, and then to protect the data line. But I'm going to use this one. Right. Is this really a Zener diode? I will connect it in the circuit and see if it works. if it doesn't work, then it's a typical diode that needs to be connected to the ground in order for it to become a stabilizing diode. Wow, this diode is so small it can't even fit here. So this will not work. Let me solder it back to the board because it can be useful in the future. It doesn't matter the orientation at the moment. Let me find another diode. Okay, so it was very difficult finding one of these diodes. So what I'm going to do, I'm going to use this diode. This is an anti-static diode as well. All three of them. Right, this side is connected. This is the anode and this is the cathode. So when the cathode is connected to ground and this is going through the data line, this side here, it will do a reverse conduction. So I'll solder this side and this side and see what I get. Since this is a two-way diode, I'll just use one way. Oh, it's a MOSFET, sorry. It wasn't a diode, sorry about that. Alright, so the ground for this thing . Okay, so right here should be ground. Yes, and this is the data line 700. Oh, I reversed my polarity. My red probe was on the power line. There's 795. Alright, so I'm just going to solder this side, this leg, and it's actually too big. I can't find one of these diodes. So I'm just going to find a way to make it work. Oh! It's blown away. I'll just use the soldering iron then instead. This diode is very small. I'll catch the ground leg over here, and then I'll just run a small wire from this side to here. Normally they would use these diodes on the latitudes, and inspiron as well, but I don't know why they didn't use it on this one, because I have these brand new in storage, but I don't have these ones. Alright, so shall we test it? See if I'm getting my 3.3 volts at that side. Alright. So let me test it. See if I'm still getting 3.3 volts. Center pin. No, it didn't work. It did not work. Oh, I see why it didn't work. I was touching another. I was touching something else. Oh boy. Let me get a different wire. It was touching on this pad here. Again. And I'll just strip a piece of wire right here. It's now 22 minutes. Alright, so let me just rock. Alright, let's try again. See if I'm getting 3.3 volts. Nope. So this diode seems it won't work. Let me find another diode. Okay, so looking at the board view here, the schematic from another board. So this is what the circuit looks like. As you can see, this is the Zener diode. This is the exact diode that I need, right? So this is the DC in. Sorry, that's not it. This is the diode that I need. Sorry, this is for the DC jack 19 volt rail. Now let me pause. Okay, so this is the diode, as you can see. So this has a diode that's in the middle here and another diode, right? So this symbol indicates that it's going to be a Zener diode, and it has a reverse conduction, and it is acting as an anti-static diode. So it's ED, and the ED basically means that it's an anti-static diode. So it's different from the regular transient suppressor diode here. So this is why this diode is so difficult to be located on another board, right? So this board that I'm looking at now is a donor board. So I'm checking the schematic now on the PSID line to see if I can find this diode, right? So I'm going to look for this diode on the board. So this is the exact diode I need, and this is going to protect this line for the PSID from going to the EC. So this is the signals going to the EC, and here's another diode. This diode is basically acting as a diode, as an anti-static diode, which is a forward conduction. If the voltage on this line exceed the reverse conduction value, as you can see, 9 volts. So if it exceeds 9 volts, then it will do a reverse conduction, and then it will stabilize it at 3.3 volts with the help of this S5. So when this, as you can see, this side of the diode, which is the anode, is connected to the ground, yeah. And then now, if any voltage induced on this line, the voltage at the anode will be less than the voltage at the cathode, so it will then do a reverse conduction. This part is a bit complex to understand. I won't go so deep. The main focus is this. Alright, so I'm going to see if I can find this diode. So it's ED4303. Okay, so I found a small one here from that board. So I'm going to try it now. So that's pin 1, connected in the right orientation. So I'm soldering it now. So hope it worked. Okay, so I'll plug in the charger now, see if I get 3.3 volts. If I get 3.3 volts, then the job is done. So let's see if we're getting 3.3 volts. 2.9, 3 volts. There we go. So I'm now getting 3.3 volts. So let's check on the oscilloscope now to see if we're getting that wave that I was supposed to be getting before. Alright, so I'm connecting my oscilloscope now. Now take a look at the oscilloscope, see if we get waveform. Nope. No wave. Nope. Let me see if I saw that correctly. Remove the diode. Alright, so I'm now gonna connect pin number 1, pin number 3. Oh no, there's a problem. Let's see if I'm getting 3.3 volts. Yep, 3.3 volts is there, but I'm not getting a correct wave, or something is wrong with the DC jack itself. Alright, one more time. This is without the diode. That's not correct. But this is without the diode, so what could have happened? This, looking here, if I dig too deep inside of the signal, I'm breaking the line. All is well. Oh, it's raining. It's raining. A rainy day. All right. Not getting the signal anymore. Checking the resistance. Alright. 786. It's good. But why am I not getting the waveform anymore? Let me check here. Ah, there we go. So the waveform is there. Let's try it one more time. Plugged in. I think something is wrong with this cable also. There's no break in the wire though. One more time. It was working perfectly. Don't know why it's not giving the waveform. The resistance is okay. 3.3 volts is there, but still not getting a wave. One more time. Still no wave. My charger, it seems there's a fault between the charger or the DC jack, because I know this thing is working. Alright, let me try another charger. Alright, trying another charger now. Same thing. Let me try another a DC jack. Okay, so found a DC jack, which is a bit longer one, but it's just for testing purpose. Alright, so take a look at the oscilloscope. Too much wires. Alright, here we go. Okay, so it worked. So it is the DC jack was the problem. There we have the waveform there. So the charger reads. So there's a problem with also the jack, the DC jack itself. Let me try the original jack. Alright, so now I'm going to plug in the power again. Then it will confirm to me that the jack is the problem. Alright, plug in the power. See? Waveform not coming, so the jack is also bad. So the jack is bad, and the board had an issue as well. Can't this thing be repaired? Looking down into the pin, but I can't see any fault there. But the jack is bad also. Whoa, I see that lightning. Oh, the center pin is disconnected from the, as you can see there, the center pin is broken. See? Look at that. Look at that. What? Look at that. The center pin is basically disconnected from the thing. Look at that. Look at that. So I'll just melt this outer coating and then just join back that wire, and my repair should be done. Look, 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 look. Just stripping off that wire there. Look at that. Some flux. Getting the other iron ready. So I'm just going to tin here with some flux, some solder, and just join it back together. So the wire was broken also. The wire was broken. Alright, let me just remove this piece here. This is heat shrink tube. Get out the way. Alright, just removing that piece there. Oh, this is so tough. Alright, let me just join this back together now. A bit tough. The wire is a bit short. There we go. I grabbed it and I pick it up. Alright, so I don't have to worry about the other. Why? Because they're already insulated. I just need to catch back this piece here, making sure it's firm. So I'm connecting it back now to the DC jack. And then I will connect the oscilloscope now and see on pin 3 again. Perfect. So as you can see, the waveform there as I remove the lead. And let's check again. Remove. So I'm just going to sort about the diode now. Connection. Perfect. Alright, so let's connect the diode. Solder the diode back to the spot now. And that should conclude the repair. Alright, dot to dot. Alright. First I'm going to check for the 3.3 volts, then I'll check signal after. Okay. Alright, check if we're getting 3.3 volts there. Dark. .3 volts is there or not? Are you there or not? Yes, 3.2 volts is there. So I will now check with the oscilloscope. Da, 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 da. Dun, 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 dun. Alright, let's keep our fingers crossed. Oh, I wasn't on the oscilloscope. Alright, let's go. Perfect, we got waveform. Ha ha ha. Perfect, perfect, perfect. We got some waveform. And I think that's the repair. Alright, so as you can see now, that one was tough. Very difficult finding one of those anti-static diodes. And the board is now repaired, so I'm going to connect it up back now, screw up back everything, and connect all the parts. So let's go and do this to the overhead camera. On the overhead. Let me zoom back out. Out. Okay, here we go. So I'm gonna put this unit together now. So the DC jack was bad and the board got a hit at the same time. I should have repaired this a long time ago, but due to that diode was so difficult to find, I had to get a schematic to see if I can find one from the donor board and replace it, because that diode is very important. My battery is dying. See if we can move as quickly as possible. Okay. All right. Alright, so I'm powering up now. Pressing the F2 key. Ah, there we have 90 watt now. And it's saying AC adapter, and it's now 90 watts, and it's now 1% for the battery. Alright, let's see if that battery level moves. Let's check and see if that moves, and then we are done. So we're at 1%, and let's check if we're going to get 2%, and that should conclude the repair. Well, we just had a nice shower of rain with a lot of thunder. Okay, so you see if this thing reaches 2%, and that should be it. We're at 2% now. Very good. So the battery is charging. I'll make it go 1 more percent, and then I'll just conclude the repair. Alright, so 1 more percent, and then I'll just call it fixed. Alright, there we go. So okay, so that concludes the repair, and hope you all learned and enjoyed that repair. It was a bit difficult finding one of those Zener diodes, or anti-static diode rather. Very important for the protection of the embedded controller. So this is why, as I said, the Dells send the 3 volts to the center pin of the charger to power the DS2505 chip inside of the charger. That has that information, which is as one wire serial communication between the charger and the EC, right? And that information is passed so that the information can send to the EC so the battery can be charged. So once the EC gets that information from the charger, then now it instructs to the charging chip to start charging the battery through the SM bus or the I2C line, right? Serial clock and a serial data. So I'm going to stop now, and I hope you enjoy. Alright, and in the next video I will fix something for you. Okay, bye.